All right, so today we're going to start talking about relations. And what is a relation? So a relation is a pair of inputs with outputs. When relations are given as ordered pairs, the x-coordinate is my input and the y-coordinate is my output. So what we will be dealing with is a lot of ordered pairs, tables, graphs, where we have an x-coordinate and a y-coordinate. So a relation that pairs each input to exactly one output is a function. Okay? So relations can be shown in multiple ways. We have tables, graphs, ordered pairs, mapping diagrams, and equations. Now today we're only going to work with the first four. Later on we'll talk about equations. So we're going to determine whether this set of ordered pairs is a function. So remember we talked that the definition of a function is that every input, so all of these all of my x's, okay, my inputs are paired with exactly one output. So we're going to look at our x values. Do I have exactly one of those? Okay, so notice that, bring my pointer back. Okay, so I've got a -1, 2, 3, and 8. Okay, so my x values do not repeat. So therefore, this relation is a function because every input has exactly one output. It does not matter that my y value for each one is a y, or is a 5. Look, can't talk this morning. Okay, because none of my x values repeat, this is a function. So let's look at another one. I have got -3. So I like to mark my x values. Because remember, a point is x and y. And we're going to look at the x values first. So in my x values, do I have any repeat? Well, we've got -3, -1, 1, and 1. So I do have an x value that repeats itself. Now we're going to look at the y values with that. Okay, so I've got -1, 1 and -3. And then I've got 1 and a +3. So, oops. This relation is not a function because one both goes to -3 and 3. All right, we're going to look at this table, and this is another relation. So we're going to determine, is this a function? So looking at my x values, I can already see that I've got -1 and 1 written twice here. Now if I go over into my y values of the table, -1 goes to 3 and -1 goes to 6. So this is not a function because -1 goes to both 6 and 3. All right, looking at this table, do I have any repeating x values? I don't. So you can say this relation is a function because every input has exactly one output. This is what we call a mapping diagram. Okay, my inputs go on the left and we only write them one time. My outputs go on the right, and again we only write the number once. So to determine whether we've got multiple repeating inputs, we have to look at the arrows going away from the inputs. So notice how each of these only has one arrow. Okay, So because each input has only one arrow going away from it, this is a function because every input has one output. Again, it does not matter that my output is the same for all three. All right, so notice here, 0 has 2 arrows going from it. Okay, this is not a function because, oops, and that's not supposed to have a negative in front of it. Ignore that. 0 goes to both -1 and 0. All right, so now we're going to talk about doing graphs. And in order to determine whether a graph is a function, we're going to use what we call a vertical line test. What is this? Well, it's the easiest way to determine whether a graph is a function. And how we use it is we take any straight edge to represent a vertical line. So a ruler, a pencil, anything that is a straight edge. We're going to place that straight edge from the left of the graph and move it the straight edge across from left to right. So if my straight edge touches no more than 1 point at any time on my graph, then the graph is going to represent a function. And this is my example here. So notice as that red line moves across, okay, we don't touch anywhere except for 1 point on that line. Okay, we're ignoring the axis. So let's determine if this is a function. It's just a set of points on my graph, right? So none, one, oh, let's look at that again. Watch when it crosses right here, guys. Notice how both of those points hit the vertical line at the same time. So, and that was at when x is 3, right? Because this is my x-axis, that's 3. So we cross 2 points when x is equal to 3. So this is not a function. We could also say this does not pass the vertical line test. All right, we're going to look at another one. So watch these dots. Notice we only hit one at a time. So this one is a function because every input, or we could say it passes the vertical line test. And is this a functional? Is this relation a function? So graph is a circle. So if we do the vertical line test, notice, let's watch that again. Notice how I touched more than 1 point several times on this graph. So this one is not, because using the vertical line test, we cross 2 points at multiple spots. All right, one last one before I end today. Let's look at this one here. So this is a set of ordered pairs. And we're going to kind of look, and do I have any repeating x values? Well, we've got -2, -1, 0, 1, 2, 1. So I do have a repeating x value. But what is my y value with it on both of those? My y value is 0. So pay attention, because when I have 2 points that are exactly the same, it is still a function because I still have every input that has exactly one output. So just because the x repeats doesn't always mean it's not a function. Most of the time it will be. However, there will be times that it's not. All right, and that is it.